All right, so I just looked in my calc book and I found all the different indeterminate forms that we talked about in the last video. So first case is 0 over 0. Let's see. The second case is plus or minus infinity over plus or minus infinity. Then there's infinity minus infinity. Then there's 0 times plus or minus infinity. And then finally there's 1 to the plus or minus infinity and infinity to the 0. So just forget about those ones I talked about last time because I wasn't really sure. These are the indeterminate forms that you need to know. And really the most common ones are these two, this one and this one right here. So now that we know how to recognize these indeterminate forms, we can learn about L'Hopital's rule. So L'Hopital's rule, there's probably like a formal definition in your textbook. But let's just say that you have the limit as x approaches some arbitrary number, let's say c. The limit as x approaches c of, say, f of x over g of x. If plugging in c to this limit gives you an indeterminate form, then you could use L'Hopital's rule. So if this limit, like let's say you plug in c, let's say f of c over g of c gives you 0 over 0 or infin over infin plus or minus any indeterminate form, you could use L'Hopital's rule, which is just take this limit and then instead of evaluating this limit, evaluate f prime of x over g prime of x. The limit, again, as x approaches c. And if that gives you another indeterminate form like 0 over 0 or infin over infin, then do f double prime of x over g double prime of x, the limit as x approaches c. So now that we know what it is, let's do an example. Let's say we have, well, first of all, first example that we should probably talk about is the difference quotient, or the limit definition of a derivative that we had from the beginning of AB Calc. Actually, h approaches 0 of f of x plus h minus f of x all over h. Plugging into this gave us 0 over 0. So this would be a case where L'Hopital's rule would work. So let's say we have the limit as x approaches 3 of x squared minus 9 over x minus 3. we could factor x squared minus 9 to x plus 3 and x minus 3 and cancel out and solve it that way. But we could also use L'Hopital's rule, because if you plug in x equals 3, you get 0 over 0. So the way that L'Hopital's rule works for this is, you, like I said before, take the derivative of the top over the derivative of the bottom. Don't take the derivative of the whole thing and use quotient rule. That's not right. Just take the top separately and the bottom separately. So derivative of the top is 2x. Derivative of the bottom is 1. And so limit as x approaches 3. So now we could just plug in, get 6. And you can see that that would have worked too if we did it the other way, where we factored out x plus 3 times x minus 3 over x minus 3. The x minus 3's cancel out. You're left with the limit as x approaches 3 of x plus 3. That's also 6. So I'd say that L'Hopital's rule is a much faster way of solving these. And in the next videos, we're going to get into cases where the only thing that you could do is L'Hopital's rule.